Module 7, Lesson 3 deals with solving one-step multiplication and division inequalities with positive coefficients. And that positive there is very important because with there being positive coefficients, these suckers work just like equations. There's no difference. The only difference between inequalities and equations comes when you're multiplying and dividing problems with negative coefficients. These are positive. It's going to be just like everything we've done before. So sit back, let's check it out. Of course, we got the objective, which goes in the title. They say this is going to be a 2-day lesson. I don't know about that because it's really some pretty simple concepts and they only have 10 resources. Let's get started. Miss Zavalos has $35 to buy pizzas for the Spanish clubs. Each pizza costs $8.50. The inequality, $8 or 8.5 times x, $8.50 times x, is less than or equal to 35, can be used to find out the maximum number of pizzas that Miss Zavalos can buy. How might you be able to use this type of inequality to solve and find out how many pizzas she can buy? This is exactly what we're going to be learning about in this lesson. Our inquiry question asks, how does multiplying or dividing each side of an inequality by the same positive number affect the inequality? Well, let's take a look at that. We got an Explorer for us here that says that Lamar, Oscar, and Nick are comparing the amount of money they have in their pockets. Write an inequality that compares the amount of money that Lamar has to the amount of money that Nick has. So Lamar has $3.60, Nick has $2.20, so we're going to take and say 3.16 for Lamar and 2.20 for Nick because Lamar has more money than Nick does, and check the answer. Our answer checks. And that leads us to the question, will Lamar have more money than Nick if each friend spends half of his money? So if you're spending half the money, you're essentially dividing the money you have by 2. So to find out, we're going to take this graph, which represents the money that Nick has and the money that Lamar has, and we're going to divide it by 2. So if we divide by 2, boom. Does Lamar still have more money than Nick? Absolutely he does. Whenever you take and multiply or divide both sides of the inequality by the same positive number, nothing happens to that sign. The only thing that changes are the numbers on each side. Lamar dropped to $1.58, and poor Nick, he only has $1.10 left. Now they want us to experiment with that divide button and change that value in the box to any positive number less than 100 and see what happens to the markers on the vertical number line to create some different inequalities. So let's take and just divide by, let's try to divide by 50. And what happens when we do that? Well, we get wee little tiny numbers. Sadly, we can't really see those, can we? But what if we were to take and come up with some new numbers here, and I set them up to where, oh, look at that sign down there. Watch what happens if the green one goes higher than the blue one. The sign changes directions, right? That's pretty cool. So if I divided that by 50, we got that. Well, let's take and actually go to some smaller numbers here, and something that we can do a little bit better. What happens if we divide it by 25? And hit enter. Whoop, not 255, just 25. And when we do that, I think I broke it. Divided by 60. No, I broke it. Oh well, y'all get the point though. It doesn't matter what you divide both sides by, as long as it's the same positive number. This sign right here is not going to change directions. So now we're going to write another inequality to compare what Lamar has to what Oscar has. Oscar has more money than Lamar, so he goes on the side the alligator's going to eat. Lamar, he's going to go on the other side. There's our inequality. Now, will Lamar still have less money than Oscar if each friend triples their money? Well, let's find out. Going back to our bar graph here, we got the graph showing what they had, and if we were to multiply both sides by 3, what's going to happen? Guess what? Oscar's still going to have more money than Lamar every single time. The sign will not change directions if you multiply and divide both sides by the same number. Moving on to resource number 4, it says you can multiply and divide inequalities by using the division property of an inequality, vocab term, and some division inequalities by taking and using the multiplication property of an inequality, another vocab term. If we looked at those in words, we would say that an inequality remains true when you divide or multiply each side of the inequality by the same positive number. Okay, key word there is positive. For all numbers a, b, and c, where your c value is greater than 0 because c is your denominator. Okay, remember in that denominator you can't have a 0. If a is greater than b, then a divided by c is going to be greater than b divided by c. If a is less than b, then a divided by c is going to be less than b divided by c. Likewise, a times c is greater than b times c, a times c stays less than a times b times c. And looking at those in real world numbers, if I had 9 is less than 15, we divide both sides by the 3. Guess what? 3 is still less than 5. If we had 10 is greater than 7 and we multiply both sides by 2, guess what? 20 is still greater than 14 every single time. And now it's time to actually start solving these things. So we have the inequality that says 8x is less than or equal to 40. Let's see if they're going to let me highlight it. Yep, it's highlighted. And it says to solve it, check your solution and graph it on the number line. That's a lot of things, 3 different things we have to do. So first thing we're going to do is solve it. As all of our other problems, you have to start off by writing the problem. If you do not write that problem down, I will not give you credit for it. From there, you're going to ask yourself, what's my variable? X. Who's X's friend? 8. What is 8 doing to X? It's multiplying. And what's the opposite of times 8? It's going to be divide 8 on both sides, and that's what you see right there. They use a division property of an inequality, divided 8 on both sides. From there, 8 divided by 8 divides out becoming 1, and 1 times x is x. 40 divided by 8 is 5. You notice your sign did not change directions at all. So your final answer, x is going to be greater or less than or equal to 5. That's all there is to doing these guys. You treat them just like an equation, except they also want us to check it and they want us to take and graph it. So for graphing the inequality, they say select an open or closed point for the endpoint and then drag the arrow to the end of the number line to complete the graph. So we have our value is going to be x is less than or equal to 5. It's an or equal to, which means I need to have a closed point on 5. Let's see if I can take and make it actually stick there. The number line. Hold on. Alright, I finally got the point to take, and now from here I'm going to say that x is smaller than or equal to 5. So from there we need to take and, leave my 5 alone. We need to take and drag a line that's going to go to the left hand side. So how am I going to do that? Drag the point to the end. Nope, that sure didn't work. Well, clearly this one doesn't want to play nice, but what you would have is a solid circle here with your arrow going all the way to the left-hand side. Sorry it won't work on the computer. And now it's going to be your turn. Go ahead and solve the inequality that you see right here. 4.5y is less than, 4.5 is going to be less than 0.5y. And we put your answer in here to check it. After that, see if it'll let you graph it down here. Hopefully it'll play nicer than it did for me. Alright, so the problem is written here is 4.5 is less than 0.5y. We're going to isolate the variable by going after the friend. The friend is 0.5. 0.5 is multiplying y, so we're going to make it go away by dividing both sides by 0.5. These divide out becoming 1. 1 times y is y. The less than sign stays the same. And then 0.5 is going to go into that 9 times. Now, yes, I did just do that in my head, but we can prove it too by taking the 0.5, bounce a decimal to the wall, bounce a decimal inside the house, same number of places to the right, and it goes up. How many times does 5 go into 45? it goes into it 9 times. From there, that's our answer. To graph it on the number line, this is what I'm going to be looking for in your homework. Where you have that 9, we're going to have an open circle because it's not an or equal to. The y is bigger than the 9, so you're going to draw an arrow to the right hand side. That's all there is to that. Coming back over to our book, we're going to say there that the y will be less than 9. I'm going to check that. Oh, hold on. Why did that say that that's not right? That is right. Wonder what it's saying. That is wrong. Oh, I see why, because they changed the direction. They flipped the order of the problem. So you can see here my y is greater than my 9. Here the y is also greater than the 9. Make a point to slow down, look at things. So now we're going to see if it's going to let us graph it. We're going to have an open circle on the 9. Nope, it's not going to work nice, so we're just going to leave that alone. Now example 2 sets up a similar type of problem where here they've got d divided by 2 is greater than 7. We're going to work it once again just like we would have worked an inequality, okay, an equation. So we're going to start off by taking and undoing division by multiplying that 2 on both sides. Of course, you still have to write the inequality first. From there, they multiplied 2 on both sides. Remember, I always tell you to put that 2 after the number you're doing it to. Trust me, you'll thank me later for it. From there, these 2's would divide each other out, leaving d, and 2 times 7 is going to be 14. So I'm going to get d is greater than 14 for my answer. That's all there is to doing these. You treat them just like an equation. Nothing special about them. From here, they'd want you to graph it. And of course, we're going to have trouble graphing because it's not working right. But if it had been working right, we would be taking and putting an open circle on the 14, which is right there. And because d is greater than it, we would draw an arrow going to the right, the side that is greater than the 14. And now it's going to be your turn to work this problem while I eat the panini I made for lunch. All right, for this one, final goal of an equation, isolate the variable. Same with the inequality. Your variable is y, his friend is 3.6. 3.6 is dividing y, so we're going to make it go away by multiplying both sides by the 3.6. I'm going to do a times 3.6 on the left, making sure it's at least in the middle, if not on the top. And I'm going to take my negative 2, I'm going to multiply it by 3.6 as well. These divide out becoming 1. 1 times y is y. The sign stays just like it was. 2 times 3.6, that's going to become 7.2. Negative times a positive is going to be a negative. So your answer is going to be y is less than a negative 7.2. Graph it on the number line where you would have your negative 7.2. We're going to have an open circle because it's not or equal to. Y is smaller than the number, so we're going to take and draw an arrow to the lower side. That's all there is to doing these. We can jump back over here and say that our y value was less than a negative 7.2 and check it. That checks. I'm not even going to try and graph it because we know that's not working. That's all there is to this lesson. Y'all go ahead and start working on your homework, and I'll be happy to answer any questions you have in class tomorrow.